listening to Ice World Podcast. I'm your host, Rob Taylor. The first maps to feature the Antarctic continent were purely speculative. The early map makers believed that it existed, but didn't know what it looked like. Ptolemy of Greece, in approximately 150 CE, postulated that there must be a large continent to the south, acting as a sort of global counterbalance to the large continents of the north. In the 5th century, a continent dubbed Australis was depicted on a map by the Roman scholar Macrobius. These early maps are remarkable in how far north they show Antarctica. In one, there's only a narrow strait between it and Patagonia, with a headland extending north of the Tropic of Capricorn to just south of modern-day Indonesia. This belief in a southern continent persisted, with map makers labelling it Terra Incognita Australis, or other names to that effect. During the 1700s, however, voyage after voyage explored the waters where this southern continent was believed to be and found nothing. Gradually, the imagined continent shown on maps diminished in size, in some instances even vanishing altogether beneath the ocean. A 1741 map by a Dutch cartographer shows open water clear over the pole. A 1749 map by a French cartographer omits the landmass of Terra Australis in favour of Terre Antarctique, Antarctic lands. While it too shows open water, the name indicates that the makers were still unsure and perhaps unwilling to discount another option. With the discovery of Antarctica in January 1820 by a Russian expedition, things began to change. With each successive expedition, more and more of the continent's fringes were seen, recorded and ultimately mapped by the likes of James Clark Ross, Mercator Cooper and James Weddell. They came searching for the magnetic pole and for sealing and whaling grounds, but each foray yielded its own trove of geographical information. How times have changed. Today it is easy to take mapping for granted. Satellites orbit our globe. With a device that fits in a pocket or on a wrist, we can know our location to within a few metres, a degree of accuracy previously undreamt of. We use this technology to find the fastest way to our destination, to see what our house looks like from space, and even to find potential dates. So Antarctica must be mapped out. Right? Today I'm speaking with Elena Field, who works for the British Antarctic Survey's Mapping and Geographic Information Centre, or MAGIC as it's known. Hi Elena, thanks for coming on the show.
Hi, thanks for having me.
What are the challenges of mapping Antarctica and what makes it different for a cartographer than other places?
So Antarctica is a really interesting place to map because of the challenge that it faces. It's an area that has largely not been mapped in any great detail. So we're talking any regional to large scale mapping. In fact we mainly rely on continental scale for older maps. So kind of 1 to 1 million or? Yeah, so that would be at a continental scale.
Yeah, it's a bit different to 1 to 25,000 or 1 to 50,000.
Yes, it's definitely not your Ordnance Survey map. Yeah, so it's a really good challenge, particularly with areas that any field scientist would go to. It's largely an unmapped area, so you're kind of mapping a place for the first time at that detail. That's quite exciting. Yeah, it is. It's good.
How do you deal with features that move? Because obviously a lot of the ice sheets are moving. At what kind of speed do they move at?
It varies quite a lot depending on the glacier you're talking about. Ice streams are quite fast moving. You're talking about the Thwaites Glacier, for example. It's moving at quite significant speeds. I'm not going to actually have numbers because then someone would shout at me. An ice stream, that's when it's trapped between two geographical features, is that right? Yeah, that's right. So such as the King George VI Sound, where Fossil Bluff is located. So it's along the peninsula. Okay. But obviously things like crevasses will tend to occur in roughly the same spots. Mm-hmm. So do you represent those on your maps? We can do. Largely that's a case of whether we can see them from the imagery that we get. At the level of imagery we get normally, it's unlikely that we'll see anything larger than or smaller than quite significant crevassing. So we're dealing with imagery that's about 10 metres resolution. Okay, so anything smaller than 10 metres simply doesn't show up? No, it won't show. It'll be a blur. So yeah, if you see anything, any crevassing on a 10 metre resolution image, it's pretty serious stuff. That's good to know. And it's a lot of it's satellite imagery then that you're relying on for these maps? For the majority it's satellite imagery. We also use a bit of aerial depending on the area. Aerial is in short supply, purely because people have to actually go across and take images. whereas a satellite will go overhead once or twice a day. So for sheer quantity, satellite is definitely the best way forward.
Cool, that's good to know. Who uses your maps? Who are you mapping Antarctica for?
So I work primarily for operations for the British Antarctic Survey. So that means anything for the air unit or for the field guides. So that involves creating maps every season for wherever they're going into the field, updating the air unit charts or maps mainly, and then they also get distributed across the organisations.
Cool. And do other organisations use maps produced by yourself and your colleagues?
They can do, yeah. So we create these air operations planning map series, which is a collaboration between a whole load of different nations, and we all share the mapping products that come out of it.
Are those the ones that have flight distances and amount of fuel it takes and things like that?
They can do, yeah. The ones that we produce, they're more detailed, so they're 1 to 1 million scale, and they have more topographic detail and more height detail for the air unit.
Cool. It's interesting to think of 1 to 1 million as being the more detailed scale.
Definitely,
So
yeah.
it's so different than we're used to. Although Antarctica is, broadly speaking, the size of Western Europe or North America, is that right?
Yeah, that's right.
It's a huge area to try and map in any level of detail.
Exactly.
Projection-wise, most of us are familiar with Mercator. You know, it's the one that we've all seen since we were kids. What do you use in Antarctica, and how does it differ? And if so, why?
So Mercator is the one that everyone's familiar with, and if you'll be familiar with it, you'll know that Antarctica and the North are completely stretched.
A bit distorted. Would
Ever
be,
so slightly distorted, yeah. So trying to do anything in that projection in Antarctica is just a no-go. So we use a variety of different projections. Primarily we use the stereographic projections, so they're the ones that are focused at the pole. So they essentially just remove the distortion. These are generally, there's a latitude of true scale, which is much easier to deal with.
And that's a latitude at which 1 mile of north-south is the same as 1 mile east-west?
Yes, exactly.
Whereabouts is that on most of your maps? So obviously it'll vary.
It'll vary significantly, but for your standard stereographic projection, the standard is 71 south. So anything contained within it, the distortion is limited as much as possible.
That's interesting. That's good to know. Yeah. Technology-wise, obviously you use a lot of satellite mapping. You said some aerial as well. Are there any other technologies that are coming in or that we should know about that might not be in the kind of public consciousness?
Yeah, so, well, with what I work with and to supply the field guides with information, we're looking increasingly into mobile mapping, so using mobile apps and on tablets and things like that.
Oh, cool.
Yeah, so it's a growing field. There's a whole new range of new apps coming out, and there's both open source and commercial available now.
Oh, so how would this work then? Say the field guide is out and they find something.
So what we do at the moment is we produce a whole load of maps in a variety of different formats, which are then able to be ingested by the tablet app of the field guide's choice. We, of course, limit that choice because there's a huge array of them available. And then if the field guide wants to, or if the scientist out there is using the map, they can then place a point on it. If it's linked to a GPS, then they'll know exactly where they are, and then that they can be used as references. The problems we face with being in Antarctica is that technology and electronics don't last very long. Their battery wears out very quickly.
I can imagine. I mean, it gets pretty cold.
Pretty
it never
chilly.
gets above kind of zero really for any length of time.
No, and if you've had your iPhone out in winter, you'll know that the battery drains like no time, and that's the case for tablets. So we have to kind of mitigate that with having the best data available, which often is on tablets or on a computer or something like that, with actually the fact that they're not going to be able to be accessed outside of the tent that they're staying in. So a lot of it is preparation before a team goes out into the field.
Right. Yeah, that kind of helps explain why it's so poorly mapped initially, and you have to do so much legwork now.
Yeah, definitely.
Are there any other things that we should know about?
Web mapping is becoming more and more important.
Web mapping, what do you mean?
So if you've seen Google Maps, that's a web map. And we use our own in-house version and other nations use their own. We use this for flight following, etc. But they're becoming increasingly important for preparing the winter teams over the winter, so you can send information down when the bandwidth is not as significantly stretched as it is now.
That's quite cool.
Yeah, so it's really good. We can send information down and prepare the field guides well before the start of the summer season when it gets really busy.
How do you represent, for example, the Brunt Ice Shelf on a map? How do you show that there's water under there, or that it's X amount of ice over X amount of water? Do you have a way of doing that?
Lots of it is down to styling. So it depends on the main user of the map. So if it's an operations map, then it's just surface level. If a scientist wanted it for a paper, then they'd usually provide us with more information, and then it's a case of discussing it with the end user and then assessing their needs. So quite often it comes to cartographic styling in the end.
And how long have you been working for Magic?
I've worked for Magic for just over 3 years now.
Okay. And have you seen any changes to any of the maps that you've made? For example, have any big icebergs broken off that have changed something that you've just made into something that's now obsolete?
Yeah, there's been a couple of occasions. So the Larsen ice shelf that carved off a couple of years back happened to be a week before one of our peninsular maps went to publication.
Oh, no way.
So we were about a week away from sending it to the printers. So it was a very rapid download satellite imagery, digitise the new coastline and then update the map.
Oh, that's really impressive that you can do that. Be that reactive to changes.
Yeah, that's why there's a mapping team in Bath.
Cool.
So,
yeah, I guess it's a fairly unique environment in how dynamic it is and how ever-changing it is.
Exactly, yeah. Things are changing all the time. Mapping Halley Station, for example, the ice shelf is constantly moving. So as soon as you make a map, it's obsolete.
100 metres a year or
something
thereabouts?
like that. Yeah, I think it varies, but roughly speaking, that. So you just means that everything you map is immediately obsolete.
That's exciting.
It's exciting, yeah.
Elena Field, thank you for sharing your expertise with us. It's been dead interesting.
Thank you very much.
The work of Magic, along with archival aerial photographs, surveyors' notebooks, hydrographic charts and maps from the 1940s can, in combination, tell us a great deal about how Antarctica has changed. Major discoveries have arisen from this technique about how far and how fast glaciers have retreated on the Antarctic Peninsula and the island of South Georgia. Much as Antarctica appeared on earlier maps, then disappeared, only to reappear again, it seems to be shrinking once more, this time for real. How much and where is for the map maker to show us. You've been listening to Ice World, a podcast on behalf of the British Antarctic Survey. If you want to know more about the survey's work in Antarctica and beyond, please visit our website at www.bas.ac.uk. Thanks for listening.